So in this video, I'm just going to give a little bit of an introduction to locating, how we go about locating where epicenters occurred. All right, there's actually a video that I think does a very good job of explaining this process called triangulation, but I just wanted to give a little bit of a background to what's used. All right, so first of all, there is what's called, there's an instrument that's used to record the this process, but there's also a graphical readout. All right, so the instrument is called a seismograph. All right, and this is what a basic seismograph looks like. They also are sometimes called seismometers. It's a relatively simple design. All right, all you have is, think of like these as little um, bits of wire, almost like the same type of thing that a wire coat hanger would be made of. All right, and that is used to hold a pencil. All right, that's sitting on top of a piece of paper. All right, so if you've ever held a piece of wire, you know it's flexible enough that it, if there's a vibration, it would wiggle a little bit. All right, so if as long as nothing's moving, this pencil would stay, exactly where it is. But if the earth starts shaking, if you want to shake the table, in front of you, you can imagine that this pencil right here is going to wiggle back and forth. All right, so ordinarily, if it's just wiggling back and forth, it would just constantly stay and make a line as it goes back and forth here. All right, but what happens is the paper is on this roll right here, and imagine grabbing the right side of the paper right here and pulling it at a constant speed towards the right. All right. Well, if it shakes, what's going to happen as that roll is getting pulled is it's going to leave a mark. All right. So in this image right here, the paper would actually being pulled towards the left, and I can tell that because that's the direction it would have to happen for the P waves to be recorded where they are. All right. So um, the name of the visual record is what's called the seismogram. All right. So a little bit about how we do this. So first of all, so when you have a seismogram, you don't know exactly where the earthquake occurred. What it tells you is how far away the earthquake occurred. All right. And we can use a little bit of an analogy that hopefully you're familiar with, and that is between lightning and thunder. All right. If a lightning, we know that lightning travels faster than the sound of thunder. All right. So what ends up happening is if lightning is really close by, you see the flash and then you hear a very loud boom, almost, within, less than a second, almost instantaneously. All right. And that's because it didn't take that long for the thunder to get to you. The lightning gets to you almost instantaneously, but the thunder takes a little bit of time. But since it's so close, it gets there pretty quick. So there's not a big gap between the lightning and the thunder. All right. So think about the P wave like lightning and the S wave. And remember, the S waves travel slower. All right, the S is for secondary. Think of that like the thunder. All right, so if there's not a big gap in time between them, all right, so, and that would, you can measure that by the distance of between those waves. That means it had to have occurred very close. All right, but what happens if lightning is really far away? Well, you still see the lightning almost instantaneous because light travels really fast. But the thunder, which is a form of sound, it travels slower, and so it takes a little bit more time to get to you. So one thing that hopefully you realize about thunder is like when there's a large time between the lightning and the thunder, that means that the storm is very far away. If there's a very short time between them, that means it's very close. All right. So, so the only thing that we can determine from one machine is how far away the earthquake occurred. All right. The way we're going to find out exactly where it happened is through this process called triangulation. And I'm going to let this video show how that works.